In this lesson, you will learn how to simplify expressions using rational exponents. The nth root, so that would mean that any index number, can be rewritten as a radical with an index of n or as a power with an exponent of 1 to the n. So we'll have the nth root, so maybe the square root, can be written as that base number to the 1/2. Or if it's a cube root, we can write it to the 1/3. Also, know that a fraction exponent that has a numerator other than 1 can be rewritten again with our nth root, but that numerator would stay in the exponent place. You can raise the entire root to the exponent or just the base number. They do equal the same thing. So let's first explain that and how that works. So we have a to the m over n. If you rewrite that fraction as a to the m times 1 over n, let me actually flip that around. Let me do the fraction first. So if we do the fraction 1 over n times m, so we can rewrite this. This part here, using our rational exponent, can be rewritten as the nth power of a. And so our exponent will stay here on the entire thing. So showing that that one still works. You could also rewrite this a to the m over n as I first tried. So let's do that one. Putting the m on the exponent and then the 1 over n fraction. So that one can be our base of a to the m with the nth root. That just helps you kind of get an explanation of why these both will be true when writing your rational exponents when they have a numerator. Well, let's see how these actually work when simplifying. Example number 1. We have 144 to the 1/2 power. We're going to rewrite them in the correct radical form. It will not be necessary to simplify. So notice our fractional exponent, it can be rewritten as a radical. The base of that fraction, the denominator of that fraction becomes our index number. The base of the exponent is our radicand inside the radical sign. So we just have the square root of 144. An index number of a 2 is not required to be written, so we would just write it the square root of 144. By the way, square root of 144 does equal 12, but you're not required to simplify. Just rewriting it as a radical is as far as you have to go. Let's look at example 2. Here we have 343 raised to the 1/3 power. So again, that fractional exponent, the denominator of that fraction becomes our index number, and 343 becomes our radicand. That's as simple as it is. This one you will need the index number of the 3, because if you took it away, you would think it was a square root, and that would have an index of a 2. So you would be required to have the 3 there for our index number. You could simplify this further. 343, the prime factors are 7 times 7 times 7, so that gives you a group of 7s. So this does simplify to equal 7, but you do not have to go that far. Let's look at example 3. This time we have 16 raised to the 5/2 power. So because we have a numerator other than 1, let's see how we'll deal with that. First of all, the denominator still is our index number. So 16 is still going to be our radicand. The 5 can go just on the 16, or, again, having our index number of 2 and our 16 as our radicand, the 5 can go on the entire radical. Both will equal the same thing. That is as simple as you would need to go. Really, you could write these without the index number of the 2. So we would write just square root of 16 raised to the 5th, or the square root of 16 raised to the 5th. They both equal the same thing. Let's look at example number 4. Here we have 32 raised to the 4/5 power. Let's see if we're getting the hang of this now. Our denominator is our index number. The 32 is our radicand. The 4, think about it's already up high, so it's going to stay up high as an exponent. So that can be either on the 32 or on the entire thing. So 32, you'll raise the entire thing to the 4th power. Again, it's already up high in the exponent, so it's already up high in the fraction, so it would stay up high as an exponent. So let's see if we can go the other way. We're going to rewrite the radicals as exponential forms, and again, not simplifying after using our radical exponents. So or rational exponents. Let's start with the 4th root of 625. Because that's our index number, it would be the denominator of our fractional exponent. So there we go. 625 to the 1/4. The index number becomes the denominator of that fractional exponent. Let's look at example 6. We have the cube root of 1,331. So we could write that as 1,331. That's our index number, becomes the denominator of our fractional exponent. So there we go, 1/3. Number 7, we need more of a challenge. Let's look at this. We've got the cube root of 8, but all of that is raised to the 4th power. So we know our index number is our denominator of our fraction. The 4, because it's up high in the exponent, it's going to stay up high in the fraction. So our simplified answer, or our rewritten answer, we wouldn't really call these simplified. We're just rewriting them using that rational exponent. Our rewritten answer would be 8 raised to the 4/3. That's it. Let's try another one, number 8. We've got the 4th root of 2,401, and that's raised to the 5th power inside that radical sign. So once again, our base is going to be that 2,401.
Hey.
Alright, so we had the 4th root of 2,401 raised to the 5th power. So our 2,401 will be our base, or inside of our radicand, or inside of our radical. No, it's the base of the exponential fraction one. I'm going the opposite way, sorry. So that's our base. The index number becomes the denominator of the fraction, and the exponent that's on the 2,401 becomes the numerator of the fraction. So there we go. So we do have some that will require a little more work, so let's look at example 9. So we have 81 to the 1/2 power. 81 to the 1/2 power. We're going to add that with 49 to the 1/2 power. Well, if you recall just basic combining like terms, you have to have the same variable with the same exponent. So I know we have some same exponents, but because our variable or our bases are not the same, we won't really be able to combine these. So we'll have to do some simplifying in a different fashion in order to add these together. So in order to do that, we can take the 1/2 here and rewrite it as the square root of 81, remembering our index number is understood to be 2. And then we can do the same with the 49 to the 1/2, make that the square root of 49. So the square root of 81, that is a perfect square, or you can do your prime factorization. It can be divided by 3. 3 goes into 81 27 times. 3 goes into 27 9 times. 3 goes into 9, and 3 goes into itself. And then we can do the same for the prime factors for 49. Again, it is a perfect square, or you can do the prime factors. 7 goes into 49, and of course 7 goes into itself. So we have 4 3s and 2 7s. And we're looking for pairs because our index number is a 2. So a pair of 3s and a pair of 7s. So we've got 3 times 3, which is 9, and 7 there. So the square root of 81 is 9. The square root of 49 is 7. Do not stop here. 9 plus 7 equals 16. So go further and actually combine those together in order to simplify. Let's look at another example, number 10. Here we have 125 raised to the 2/3 power. We're going to subtract 16 raised to the 3/4 power. So again, let's rewrite these as radicals in order to simplify them before we can subtract their values. So our index number is going to be this 3 that's from the denominator. The 2 is our exponent. So I'm going to leave the 2 on the outside of the entire radical. You could square the 125, but then that's a much bigger number that you have to do prime factorization for. So I'm just going to leave the 125 to the cube root of 125, and then I'll square whatever I get for that. So the same deal over here. Let's rewrite. The 4 becomes our index number. The 16 is our radicand. So all of that is raised to the 3rd power. Once again, the 3 could go on just the 16, or it can go on the whole radical. For the same reason, I don't want to have to deal with 16 to the 3rd power and get that really large number and then have to do prime factorization for that. So let's do prime factors for 125 and 16. So 125 can be divided by 5. That gives you a 25. We'll divide by 5 again, and a 3rd 5. So we do have a group of 5s, and we need 3 of them as our index number shows us, which is exactly what we get. And let's do, for the 16, prime factors of 16, we'll divide by 2, divide by 2, and divide by 2, and there will be 4 of them. 2 times 2 times 2 times 2, there's 4 of them, which just so happens to be how many we need because of, again, our index number. So we have a group of 5s, 1, 2, 3 of them because our index number is a 3. So all of that cancels out and becomes just a 5. But don't forget your exponents squared. Here we have 1, 2, 3, 4 2s because that's what our index number tells us we need also. All of that cancels, so 2 to the 3rd power. So we'll simplify by taking 5 squared, which is 25, subtracting 2 to the 3rd, which is 8. 2 to the 3rd is 2 times 2 times 2, so that equals 8. And 25, take away 8, is 17 for our simplified answer.